You used AI this morning. Maybe ChatGPT wrote your email. Maybe your phone recognized your face. You did it without thinking. You never wondered what made it possible. This chip did. NVIDIA Blackwell. 208 billion transistors connected so precisely the margin of error is smaller than a virus. It powers every major AI you've used this year. And it shouldn't exist. The physics said you couldn't connect two chips this way. NVIDIA had 18 months to prove them wrong. This is how they made the impossible ordinary. By 2023, AI hit a wall. Not software, physics. Training. GPT-4 required 25,000 chips running for months. The next generation would need 10 times that. Data centers were hitting power limits. There wasn't enough electricity. Moore's law is dying. At 3 nanometers, physics stops cooperating. Electrons leak between transistors. You can't make chips smaller anymore. So NVIDIA tried something else. Make two chips act like one. Think of it like two water pipes side by side. The water needs to flow between them instantly, as if they were one pipe, two chips, zero delay, one brain. The challenge: AI needs instant memory access. NVIDIA needed 10 terabytes per second, 100 times faster than anything that existed. The solution sounds simple. Put two chips so close they touch. The reality is insane. Two processor dies connected by 10,000 copper bridges. Each bridge 5 micrometers wide. Thinner than a human hair, thinner than pollen. The bridges must align within 1 micron. That's 1/1,000,000th of a meter. Miss by 2 microns and you've destroyed $15,000 of silicon. Here's the scale that should terrify you. TSMC machines that place these chips cost $500 million each. They use lasers to measure distance. They correct for Earth's rotation. The yield, chips that work, is 60%. 4 out of every 10 Blackwells are destroyed. $15,000 each, scrapped. But the 6 that work can do what no chip has ever done. 10 terabytes per second. Enough to stream every Netflix show ever made simultaneously. The two chips communicate so fast they don't know they're separate. 208 billion transistors, more than every star you can see on a clear night. The connection became the breakthrough, not the chips, the connection. October 2024. For the first time in 30 years, the world's most advanced chip is made in America. TSMC's Phoenix facility. $40 billion. 4 years of construction. Jensen Huang signed the first wafer on American soil. Why Arizona? Taiwan is 3 hours from mainland China. If that supply gets cut, by war, blockade, anything, every AI company stops. The AI that writes your emails, drives your car, diagnoses your health depends on chips made in one place. China is building fabs. Europe is investing billions. The US spent $52 billion on the CHIPS Act. The country that manufactures the best chips wins strategically. The chip in your phone was made in Taiwan. The chip training AI you use today was made in Arizona. You just never noticed. Let me tell you about heat. Blackwell generates 600 watts. Enough to boil a liter of water in 2 minutes, continuously. The chip is 1.5 centimeters across. All that heat in something smaller than a postage stamp. If you don't remove it, the chip melts. Silicon reaches its melting point in seconds. NVIDIA built a cooling system more sophisticated than most car engines. Liquid coolant flows through microscopic channels, circulating 60 times per second. Above, a copper heatsink with 3,000 fins optimized for airflow. The engineering that keeps Blackwell cool is as complex as the chip itself. Without it, AI doesn't exist. Blackwell delivers 4 times the performance per watt compared to the previous generation. When you're running 50,000 chips, that's the difference between profit and bankruptcy. Power efficiency isn't boring, it's survival. Microsoft bought 250,000 Blackwell chips. Meta ordered 300,000. Amazon, Google, Oracle. Every cloud provider competed for allocation. Demand exceeded supply by 5 times. NVIDIA's market cap hit $3 trillion in November 2024. First semiconductor company ever. Larger than the UK's entire GDP. Here's why this matters to you. Every time you use ChatGPT, your prompt travels to a data center with racks of Blackwell chips. Your question gets processed. Answer comes back in seconds. When your phone recognizes a song, Blackwell processes it. When your camera blurs backgrounds, Blackwell calculated the depth. When your car sees a pedestrian and stops, Blackwell made that decision. You've used it dozens of times today. You just didn't know it. Next year it gets better. AI that writes naturally. Voice assistants that understand context. Photo editing that looks professional. The faster Blackwell gets, the smarter your phone gets. You're watching your future getting faster. Jensen Huang didn't invent the transistor or AI. What he understood was simpler. Control the manufacturing, control the future. Blackwell proves innovation alone isn't enough. Apple invents, Google invents, Meta invents. None can manufacture chips at this scale. That ability, designing something impossible then producing millions, creates lasting dominance. Design genius meeting production mastery separates leaders from followers. Most do one. Very few do both. Here's what you've learned. The chip you never thought about is the reason AI exists. The factory you never heard of determines whether America leads or follows. The cooling system you can't see is as important as the chip itself. Tomorrow, when you ask ChatGPT a question, you'll think about the chip processing it in Arizona. When your phone recognizes your face, you'll think about the 10,000 copper bridges connecting two impossibilities into one reality. You'll never see AI the same way. Intelligence isn't magic. It's manufactured at scale, with atomic precision, in buildings that cost billions. Control the manufacturing, control the intelligence, control the future. Next time, how Samsung uses 50,000 of these chips to design the next generation. AI building AI, the factory that builds itself.